Good afternoon, everyone. Thanks for joining our webinar today. My name is Philip Musegas. I'm the Executive Director at San Diego Coastkeeper, and we are very honored to have Professor Mladenov and Professor Biggs here today to talk about the research that they've done on the Tijuana River and how that, we'll talk a little bit about how that relates to our policy work and our advocacy to address the Tijuana River sewage crisis. Today's webinar is one of a series that we are doing this year in tandem with the Tijuana Waterkeeper, Proyecto Fronterizo de Educación Ambiental, which is our partner organization in Tijuana. We are doing a series of webinars to kind of provide the public with some background information and history and context for the Tijuana River crisis. And so this is our third, I think, in a series. And we're just, again, very happy to have Trent and Natalie here with us today. Um, so I'm gonna turn it over to them, give a quick intro, and then they'll talk about the research. So I just want to start by introducing Professor Mladenov. Natalie is a professor of environmental engineering, and she is the William E. Leonard Jr. Chair, the Endowed Chair of the William E. Leonard Endowment, the Director of Water at the Innovation and Reuse Lab at San Diego State University in the College of Engineering. So we're very, very happy to have Natalie here. And then I will briefly introduce Trent, who will follow Natalie with the presentation. Trent is a professor of geography at San Diego State University and works on hydrology, water quality, and sediment issues throughout our region. And both of them do a lot of really interesting research that I think you all will be very interested to learn about today. So without further ado, I will turn it over to Natalie and for her presentation. Thank you.
Okay, thank you, Philip. Thanks to you and also to Coastkeeper, San Diego Coastkeeper, for having us and giving us a chance to talk about what we've been doing at San Diego State University. So I'll start us off talking about the in situ estuary and river monitoring that we've been doing, looking at the Tijuana pollution crisis, and also talk a bit about some of the changes to the hydrology, to the flow in the Tijuana River, and how those have impacted water quality. And then I'll end with some sustainable solutions. Then I'll turn it over to Trent, who will talk about remote sensing aspects of our work and specifically things that his team has been doing in satellite-based remote sensing and ground-based remote sensing. Okay, so as this old photo here from 1937 shows, the Tijuana River has been cross-border flow is not a new thing. It's been happening for a long time. And as Tijuana's population has grown and infrastructure has not been able to keep up with the pace of that growth. And so this issue has resurfaced over and over again, especially as we have infrastructure failures. And those issues have resulted in several treaties between our two countries to try to address this problem. I also like to think of this as not just a sewage problem, it's really a three-headed monster, like this Cerberus dog here. So we have sewage, but there's also sediment and also trash that is in the water. So these are three interconnected problems. And the combination of these pollutants can, when this type of water gets into the pumps, it can really damage those pumps or cause real failures also in the conveyance system. So that infrastructure, when that fails, that could be, weeks or months before those are repaired and extremely costly repairs that then hinders treatment and results in untreated water crossing the border. Also, another problem is just the sheer volume of wastewater that makes its way across the border. The international treatment plant, that's the treatment plant here in the middle. The yellow icon shows it was designed to receive 23 million gallons per day or less of wastewater. But flows these days have been easily twice that number. So both Mexico and the US are, as a result of the Minute 328 treaty, we are spending or soon to be spending hundreds of millions of dollars to undertake these infrastructure improvements, like increasing the capacity of the international treatment plant and fixing broken pumps and collection systems and so on. And so then the most recent, last year's treaty, Minute 333, calls for a real-time binational monitoring system. And so that's real important. That's going to help track coastal conditions, track, public health risks in case there are future, cross-border flow events. And it'll also help us all assess effectiveness of, these infrastructure investments. What we want to be able to, after all, we've been spending or will be spending hundreds of millions of dollars. And so we want to ensure that there is indeed improvements to the water quality. And then for real-time monitoring part of that, of course, that means sensors, and sensors definitely are available, but they do need verification or ground truthing. And so that's where we come in. Thanks to funding we received back in 2021 from the J.W. Sefton Foundation and also later from the EPA, we've deployed sensor platforms at several locations, both in the Tijuana River and then also in the estuary. And this photo shows our team getting ready to do some sampling to evaluate the performance of one of the sensor platforms, the one that's in the estuary. And so with the sensors, we monitor basic water quality, pH salinity, and so on. And we're also been looking for indicators of wastewater that can specifically tell us when we have, really high wastewater derived pollution in the water. And so choosing water sensor is not a water quality sensor is not the easiest thing, right? There's a lot in water, in wastewater, from pathogens to pharmaceuticals to industrial chemicals. But very few of these are really specific or more specific to wastewater. If we want to track wastewater, caffeine and other pharmaceuticals are great because they are found in high concentrations in untreated sewage. HF183, that's another microorganisms that's great to track, but we don't have real-time sensors for those. The things we do measure in real time are, often chemical indicators like pH and salinity, and they may not be specific to wastewater. So we're looking kind of for the merger, where do these overlap? And there's a property that is true for, that is found in different types of chemicals in wastewater, which is fluorescence. So these chemicals absorb light and then they emit that light, that energy in the form of light, and that can be measured with in situ submerged sensors in the water. Okay, so we have, as I said, the sensor platform in the Tijuana River estuary at the Boca Rio site. It's shown here in green. That's where the sensor platform is. And we want to understand how well do the fluorescence-based sensors track, different wastewater pollutants like bacteria in the estuary. And so this is a screenshot of the web-based platform that we have. So via telemetry, we get our water quality data sent, and it's viewable on this website. We are measuring properties such as pH, turbidity, but also in yellow, we see the fluorescence sensors that are also shown. And I also want to point out that the Tijuana River National Estuary Research Reserve, they've been maintaining this platform, and they have real-time water quality data. A lot of these parameters are available on the website that I show here, the Turner website. Also, a big shout out to Trent, really, for all of the work he and his team did for actually deploying this platform. That was no easy task. And you can also see in the image on the right that I've got a sensor here of a photo of the sensor itself. So one of the limitations is the frequent need for maintenance. Everything needs maintenance, especially in the estuary environment. You have trade-offs. You're getting rapid, real-time data, and that means there will be other limitations to the way these optical sensors can work, and they do get fouled. And so we find everything in there from, biofouling on the lenses to small crabs inside and things that need to be removed. So that is something that the Tijuana River National Estuary Research Reserve has been doing, maintaining these sensors, and that's a big job. So to ground truth or verify the sensor data, we do water sampling. Now, direct water sampling is, of course, another way of monitoring water quality, and Coastkeeper does a great job of that. We've collaborated together with Coastkeeper on some spatial sampling, but that does get expensive and it's not real time. So verifying the sensors is an important job, and seeing, what is it that they're able to tell us, and can they give us a real sense of water quality changes. So here I'm showing, we've collected dozens and dozens of samples in the Tijuana River estuary. And here I have plotted the bacteria concentrations from those samples. These were collected in 2021, 2022. So there's a wide range of data from that we collected at that time. And I'm showing on the x-axis different types of indicator bacteria, total coliforms, E. coli, and Enterococci. And on the y-axis, we have our sonde, which is our real-time sensor, and the bottom graphs. And then at the top, I'm showing the benchtop instrument. This is located in the laboratory. It's a very high-quality instrument that does very well. It correlates very, very well with bacteria concentrations. But surprisingly, the in situ sensor also did very well. And all of these correlations that I'm showing here are statistically significant. We published this data in a journal 2 years ago. So you can see at the bottom right here is the link to our paper. Okay, so this gives us a good order of magnitude level indication of fluorescence, an indication of bacterial contamination. We've also evaluated how these sensors work with percent wastewater by doing percent wastewater addition experiments where we add 100% untreated wastewater to river water or seawater. And we do see that the benchtop instrument, all the way up to 100% is an excellent indicator for percent wastewater. Now the in situ sensor it performs really well up to 20-30% wastewater, and then it starts to plateau. And that's something that happens with optical sensors. When the water gets too cloudy, too dark, you get this inner filter effect, and then the fluorescence gets depressed or plateaus. So there is a difficulty of measuring, really, really high concentrations of wastewater. So that's another limitation of our instrument. But even despite all of that, when we have real data, we do see we do see the fluorescence respond well to water quality changes. So this graph on the left is showing the flow rates in the Tijuana River at the border. Okay, so that's the daily discharge. And then the red dashed lines shows the time where we switched from intermittent flow to perennial flow, so everyday cross-border flow. So you may remember those days when we used to hear about, 20 million gallons per day was discharged, there was a sewage spill, and that was a one-off event, or, sometimes it was more frequent. But since 2023, it has been every single day continuous cross-border flow. And that's reflected in our fluorescence data from our sensors in the estuary. So the tryptophan fluorescence is at the bottom right here. Now there are some gray blocks where our fluorescence was not being measured because we have to take the sensors out, the sondes out for cleaning and maintenance. But if we look pre-2023 and post-2023, we do see a difference of about 50 to 100 parts per billion increase after we went to that consistent cross-border flow. There's a lot of variability here too, because we do have that tidal influence that I'll talk about in a moment. Also want to share just another example of this is directly from our website, of where we get the real-time fluorescence data. On the bottom is the discharge at the border. So that's from the IBWC website, where you can look up daily discharge anytime. That's publicly available. That's the discharge at the border, and we see this is back in November of 2025. There were times where we had zero flow during the day, but then flows were just coming over at night. Okay, so there were some repairs and water was being diverted during the day. And so we only had nighttime flows, and that actually caused a real improvement in water quality in the estuary. And you can see that with the tryptophan fluorescence at the top, it's really low. And then there was a shift back to that 24-hour consistent cross-border flow, and that we've seen that since November now. It's been just flowing kind of continuously day and night. But you see, again, a big shift in the tryptophan fluorescence. Again, there is a lot of variability because of the tidal cycle that happens in the estuary, but this is still important that our sensors really do reflect these shifts, and we can see it in real time, as that water quality changes. So another key observation from our work, kind of going away from now the sensor to the actual sampling and the water quality that changes that have been happening, we see that daily tides and biweekly tidal cycles, like the spring tide and neap tide, that's kind of at the top right there, those tidal conditions do have a major influence on water quality. Neap tide in particular, that's where we have one major high tide event per day. These seem to be the worst for the estuary. Neap tide results in real estuary, kind of long-term estuary stratification, and the pollution gets concentrated in kind of that near surface zone. On the left, I'm showing ammonia and E. coli. Of course, we measure a lot of different parameters. These are just two as an example. So this chemical ammonia, that's high concentrations of ammonia and ammonium in wastewater. We see that they're during different two daily tidal, low tide, high tide conditions. During our later high tide event, the concentrations really increased in the near surface area zone. And then as you get into depth, I'm going to just superimpose an image here. Okay, this is just an illustration, but it kind of shows the bottom has this higher salinity, clean seawater coming in, and then you have that polluted fresh water, but it is, wastewater derived at the top. E. coli concentrations also are extremely high, and this, 5 million organisms per 100 milliliter sample, that's a lot. That's similar to what we see in untreated wastewater. Also, switching gears now to show you some of our results from our spatial sampling along the Tijuana River. On the bottom right is a map that shows our different sampling sites with yellow dots there. And those are also shown in this graph at the left, going from 0 at the left at the border all the way down to the estuary. And we see that for all of these different parameters that we're measuring, the concentrations are, first of all, are very high, as they would be in untreated wastewater, and they don't really decrease with the distance. Now, we were expecting that because of sunlight penetrating and degrading through photodegradation or bacterial degradation of these organics and other chemicals, we expected that there would be a real decrease with distance. But it's very unexpected. We're seeing just high concentrations throughout. So concentrations that are very similar to wastewater, even getting into the estuary. Of course, when you get into the estuary, you get more mixing, a little bit more dilution. My graduate student, Alexandra Grant, she calculated the loadings of different chemicals. And just as an example, for nitrogen, what we're seeing is 1,360 metric tons on average of nitrogen going into being exported from the Tijuana River into the ocean. Now that's the equivalent of more than 350,000 bags of fertilizer being dumped into the ocean every year. So that's a problem. And of course, there are all these other pollutants as well. But this was, I think, a good example of the load and the flux of pollution going into the ocean, and that certainly can have affect our coastline, coastal ecosystem, algal blooms, and so on. Okay, in addition to dry weather monitoring, we have also been monitoring during storm events. And this set of graphs here is showing average concentrations in red for samples that were measured in the Tijuana River at those same sampling sites during dry weather. In green, it's during storm events. And then we compared the dry weather and the storm event concentrations to typical wastewater from a large number of wastewater samples we have. And wastewater, of course, is the highest, but our dry weather conditions are really producing, some of the worst water quality. And storm events have, lower concentrations. So that was at first surprising, but then we realized, storm events, after all, do have a lot of runoff rainwater that can dilute that concentrated wastewater that's in the river. Okay. think that's important to note that the dry weather conditions that we've had, continuous cross-border flow of during dry weather is been very high, and that can result in toxicity to organisms. Um, and it could be a real problem. So, to conclude our monitoring, this is just sort of some snapshots of what we've done. We've seen that the in situ sensors alert us to changes in water quality, but have limitations. And then that shift in December 2022, January 2023 to continuous cross-border flow has really resulted in some of the worst water quality we've seen since we began monitoring. Dry weather flows are actually more concentrated than the flows that come through during storm events, even though those are larger volume, they're less concentrated during storm events. And then since 2023, the Tijuana River has been exporting, thousands of tons of nitrogen and other pollutants into the Pacific Ocean. And I think that's something that we do need to pay attention to. Um, on kind of maybe bright side, thinking about some sustainable solutions, I think it's important to end with this before I turn it over to Trent. A lot of well-informed people have been coming together and laying out different plans for how to solve this problem. And I think one of the best reports I've seen is this one that just came out last month. It's called the 5-Pillar Framework for Binational Solutions, and it's put together by former EPA and IBWC uh, authors, and they list a lot of great steps, and I think the ones that have really resonated with me, of course, the whole report I think is what we need to be doing, but some highlights that I want to share are that they talk about finishing what we started, completing that the minute 328 planned rehabilitation of the treatment systems and pumps, and expanding those treatment plants, funding for maintenance. I think that's a real big one. Rather than being in crisis mode and just reacting when something breaks down, being able to have those funds there for maintenance is critical. And then finally, we do need a plan for the long term. And they talk about, finding funding for wastewater reuse projects. And so I want to summarize, I want to spend just a little bit of time talking about water reuse. It's what I teach. I'm very passionate about it. And I think here's a place where it really can make a big difference. So first, let's start by looking at this region. This is a satellite image, and I'm going to superimpose on this the Tijuana River watershed. So the watershed boundary, that is, that's the highest point, highest elevation. And then the water flows downhill, from high elevation to low elevation, as we all know. And so it's always going to flow into the Tijuana River estuary. No matter what we do, all the water, wastewater, stormwater, that's where it will flow. And when pipes break or pipes rupture, the water will go to the Tijuana River estuary. It's just not possible to do any geological routing, right? So the funding that has been allocated is meant to repair the infrastructure and expand both the international treatment plant in the United States and the facility in south of Tijuana there, the San Antonio de los Buenos facility. And when these projects are complete, we'll be discharging treated wastewater to the Pacific Ocean. And I think that's a missed opportunity. I think we have a real chance here to take that treated water and do something beneficial with it. We are, after all, in a very water scarce region. And as many have pointed out, this water should be reused. Just from the international treatment plant, that would be 50 million gallons per day of water that could be treated with advanced processes. And these are processes, treatment technologies we have, and we've had for a long time, for decades. So in that 5-pillar report, they also talk about water reuse, and they talk about using existing treated wastewater in Tijuana. So I didn't talk about these two plants yet, but there are two facilities on the eastern side of Tijuana, the Arturo Herrera plant and the La Morita plant, and they discharge right now treated wastewater to the Tijuana River. And instead of discharging to the river, that water can be treated to a high level where it's available as drinking water and then rerouted to Rodriguez Reservoir. Now, some people have there's maybe a little ick factor with that. I'm going to tell you, this is something that we've, like I said before, we've had the technologies to do this for a very long time, and we are doing it. San Diego is already reusing wastewater that's been used for landscape irrigation through our purple pipe. We're taking that water, treating it to a higher level through our pure water project. And this is something that Orange County has also been doing since the 1980s. The technologies are tried and tested. And I also know that because I teach about this field and how to design these systems. There's also a large volume of water, of course, at the South Bay International Treatment Plant that I just mentioned, 50 million gallons per day. And there's also sufficient land area to support these advanced treatment facilities that need to be constructed for that. Um, and so why would we do this? So, well, right now, we all view the Tijuana River as a liability, as waste that we all need to pay essentially to get rid of and send that to the ocean. And instead, if we make the Tijuana River water valuable, of the value to meet our regional water supply needs, don't you think that we'll all do what it takes to protect that water supply? We will. There'll be a real dedication to maintenance and repairs. Also, wastewater is more than 99% water. And also, we should realize, our Colorado River water that we are all getting, Tijuana as well as San Diego, that water has been used by more than 60 communities upstream who've discharged wastewater. They've used the water, then discharged the treated wastewater into the river. So we are already drinking reclaimed water. It's already a de facto potable water reuse that we are doing. So this is just a more intentional treatment that actually results in very high quality water. Rodriguez Reservoir has Colorado River water in it. So just like all of our western states, now that the Colorado River is drying up and there's a lot of conflict about who will get that water, our region needs water and we're facing a critical situation in terms of water scarcity. There are, who would pay for this, right? So one thing is maybe we can rely on the governments of Mexico and the U.S. to pay for water reuse improvements. Those are federal decisions and can be slow and hard to come by. But with the recent conversations over water rights and diminishing Colorado River, there have been a few projects proposed. This is a kind of on this website by the Water Infrastructure Finance Authority of Arizona. They have compiled some different projects, and one of them, you can click the QR code here to see them. One of the projects is South Bay potable water reuse. So this is just what I was talking about. Take the South Bay International Treatment Plant and then create a water reuse facility there. And one way to pay for that, though, would be for some sort of agreements between Arizona and other states to finance it, and in exchange for Colorado River allocations. So that's not my idea. That's an idea that's already been proposed. Again, up for discussion, but certainly discussing this is the way we get towards implementing more sustainable solutions. And I'm just going to end with this slide before I turn it over to Trent, that, it's not just drinking water. We have a lot of other uses besides drinking water. So non-potable water reuse is really important. And I want to share one great example of non-potable water reuse for landscape irrigation that has been happening in Tijuana actually since 1988. So I work with colleagues. This is a study here that we did together, my colleagues from El Colegio de la Frontera Norte. We studied their treatment plant. It's called Ecoparque. They built it in 1988 on this dry hill slope that you see in the photo on the left that takes wastewater from the hill, the communities at the top of that hill. And then the wastewater goes down via gravity to the treatment plant. It's very low energy, low maintenance. And just 10 years later, the picture on the right shows that this site has become Tijuana's fourth largest green space. Okay, so this landscape irrigation use of water is really, really amazing. It creates valuable green spaces that have a lot of, really multi benefits. It keeps that wastewater from flowing to the Tijuana River. That's important. And also the vegetation that grows can stabilize the slopes and keep the sediment from eroding. And so now we've got we've got a way to cut at least two of those heads of that three-headed monster that I showed earlier, the sediment and the sewage. So anyway, with more sites like Ecoparque, I think we'd have, if we can replicate this in areas where it works, where it makes sense to do so, we'd have another sustainable solution that can really make a difference. Okay, so I am going to stop sharing here and turn it over now to my colleague Trent to talk more about some of the remote sensing work that's been happening at SDSU.
Great. Thanks, Natalie. Um, Great. So, yeah, as Natalie was talking about, the discharge of the Tijuana River at the border fluctuates over time. So here's just a little, this is near real-time conditions. It includes a data point from this morning at 8:45. Let me show my slideshow. Um, so right, the conditions as of like April 9th were around 2 cubic meters per second, maximum to like 1.5 minimum. And so just for perspective, 2 cubic meters per second is like 46 million gallons per day or about 530 gallons per second. So that was the peak. And then on at the night of April 9th, the discharge fell by about 50%. Now we've seen this before, maybe more than 50%. And we've seen this before where September 11th of 2024, I believe, was the discharge fell to almost zero flow at night. And but then bumped back a few months later to this now 46 million gallons per day, but now it's down to maybe 20 million gallons per day. Don't quote me on that number. I haven't done the calculation exactly. Um, so the take-home message of this slide is that the discharge in the river is changing really dramatically and rapidly over time. And you see this 24-hour oscillation that has to do with when people use water and when wastewater is released into the river. So this sort of pulsing of the urban environment and its metabolism. So what does that look like on the ground? This is a video that I took at Saturn Boulevard, and this is about 1.5 cubic meters per second. Um, and this was taken in earlier April. And this is just downstream. This is just at Saturn Boulevard, and this gives you a sense of what the water looks like and what that flow rate of around 1.5 cubic meters per second looks like. So it's pretty dramatic. It's it's loud. There's a continual waterfall there. So just to give you a sense of what it looks like. So things are changing all the time in the river, in the estuary, and in the ocean. And so how can we monitor the changes that are happening in the environment? And Natalie gave us a great sense for how some in situ monitors can monitor what's going on in the estuary, as well as, and we've deployed one of these in the San Diego River as well. But I want to give you a flavor for how some other techniques like remote sensing and modeling can help us understand how the whole system, including things that we care about, like water quality in the estuary and along the coast, change dynamically over time. So a lot of this work was led by Dan Souza, funded by NASA and NOAA, in addition to the J.W. Sefton Foundation, which is an ongoing funding source for this. We're asking questions like, how useful is remote sensing for monitoring and understanding pollution in the estuary and the near coast? And so there's a few different instruments and things we can use. I'm going to focus most on the satellite based, but there are portable instruments like this NICS spectrometer that hooks up with us with just a regular smartphone and is a relatively cheap, about $1,000. You can get one of those, and you can take a sample and get a sense for its quality. We also have near surface cameras like this downward pointing camera that we have mounted on our buoy that also records not just in RGB, the three wavelengths that our cameras work in, but in hundreds of wavelengths of light that allow us to map water quality. And then satellite-based instruments, both in visible and radar, which can see through clouds, and there's links that we can have to modeling. So we've tested out this little handheld spectrophotometer. Uh, Depends on where you get it from, but like between 1,000 and 1,500 bucks, 31 wavelengths of light. You can take a water sample and put it into this spectrophotometer and get the full wave spectrum reflectance. And we tested it with all these different little points in the ocean. This is in cooperation with Scripps, who did the actual sampling, and Hadley Mank, a Scripps student who worked with Dan to write up these results. Um, and, you know, decent as a first flag for both chromophoric dissolved organic matter or colored dissolved organic matter, the stuff that makes your tea and coffee brown, parts of it. Um, and then tryptophan, which is something that's more directly related to bacteria concentrations. So not too bad, and could be used as a preliminary very quick in-field water quality scanner. So Natalie mentioned the wastewater addition experiments that we did, and at the same time we mounted a camera, the same camera that's mounted in the estuary, and we can really see how the spectral response or the reflectance, the light that gets reflected from the water changes as you add wastewater to it. So we're optimistic that this will allow us to select key wavelengths of light that are responsive to changes in water quality. Um, we can also then use optical remote sensing, and this is a picture. The pier is the white line up top, and then the Tijuana estuary are these things from blue to yellow and green, and then the coast showing a plume event on in that we sampled in March. And so we sampled starting at the condominiums, starting at Imperial Beach at Pier actually, and then going down the shore all the way to the river mouth. And pretty good correlation with what we see in the water in terms of turbidity. We're also testing this for dissolved organic matter and the bacterial indicators, and correlating these with measurements made both by us and by the city of San Diego. The other thing that you'll notice is that the water quality varies a lot within the estuary. So we really do need some of these remote sensing techniques to help us flesh out our understanding of how the estuary responds to uh, water quality changes as a result of the changes in the Tijuana River. But a lot of the time it's cloudy. But there is, and this is work done by Aaron Riley, one of Dan Souza's students that I'm co-advising. And there is radar on a satellite called Sentinel, and it can map plumes even under clouds. And it has some problems, radar interferes, but it can map it waves can interfere, but about 5 to 20 meters spatial resolution, pretty good. And Erin compiled the series of plumes that she was able to see with radar from 2023 to 2025. And what really surprised us was that the most persistent and intense plume was not at the mouth of the Tijuana River. It was actually at the San Antonio de los Buenos wastewater treatment plant. Um, and so this technology is based on the water surface smoothing slightly as a result of the oils that are present in sewage. Um, and it's a flag that there is detectable wastewater discharge at De Los Banos, which we knew all along, but to see it in comparison with the Tijuana River is really quite helpful for putting these two sources in perspective. And we want to use this technology to continue monitoring over time. How do those plumes change as a result of infrastructure installation? But we also need samples in Mexico to better understand um, what bacteria concentrations are associated with these different plumes that we can see in the radar imagery, and how do those plumes originating from those other sources impact water quality in the US. And that's where we get to collaborations that we're doing with UCSD, Falk Feddersen, Sarah Giddings, and their teams to validate their modeling efforts with some of the wastewater mapping and water quality mapping that we're doing using both in situ measurements and with the satellite imagery. And you can access their real-time forecasting tool with this link. And so, the conclusions are that real-time monitoring of water quality is feasible with the in situ monitors and with some more uncertainty with some near surface hyperspectral cameras. Um, we do know that the contamination varies a lot over space and time, and Natalie showed even how it varies with depth, that you get this pulse of fresh water that goes back and forth over the salt water in the estuary and probably in the ocean as well. But we need to know how water quality is going to respond to changes in wastewater flow. How much pollution does the estuary remove? What's the ecosystem service of the estuary? Um, what is the ocean water quality, particularly in Mexico, where the remote sensing says there's a persistent plume? Um, and more importantly, in order to constrain the models, we need to know what the wastewater discharge rate is from the De Los Buenos plant, and especially have a stream gauge installed would be a real contribution to our knowledge. For that, we need regional partnerships, lab intercomparisons, and coordinated campaigns. And we're really looking forward to working with our colleagues to answer those questions. So, yeah, thank you for your attention. Look forward to answering your questions. And we do have a list of references where you can look for additional information. And this will also be available online. So I'm happy to answer questions. And yeah, thanks. So
Okay.
I guess Natalie and I can
Well,
open up the Q&A.
yeah, I'm seeing a question there. I'll read that. Our first question is, does microalgae, do those concentrations in water coming from Tijuana, are they an issue that influence or affect sensor function, um, or the registration of the data? I think I understand. These sensors are optical sensors, and yes, algae also have fluorescence. And so that could pose I could see why we would think that could pose like an interference. The thing is this, that the tryptophan-like fluorescence coming from wastewater is at a different optical wavelength than the algae. And so even if there is algae, we're not likely to see it. The algae fluorescence from chlorophyll is at a higher emission, excitation and emission wavelength. And so yeah, the tryptophan fluorescence is more attuned to kind of wastewater derived chemicals that are at low excitation emission wavelengths. So thank you for that question.
I will say that one of the we do get interference from other things that's in the water, especially during storm flow, like sediment is a big problem because it absorbs all kinds of wavelengths and reflects all kinds of wavelengths. And so the real-time monitors work best um, in dry weather conditions where the sediment isn't super high. And then with storm flows, it gets a lot more uncertain. We have the opposite situation with the remote sensing, which is during big storm events, you can really see the plume clearly because there's a lot of sediment in it. Um, and so the remote sensing can really help us understand the distribution of wastewater and sediment during storm events. So yeah, you're right on that can be interferences of some other things that are in the water. Yeah.
Excellent. Any other questions any folks want to put in the Q&A? There is a question from Pat McDonough. Can you both see the Q&A? Yeah,
Yeah,
great. Yeah.
I can read this one and maybe take a first crack at it as well. So what is driving the recent hydrogen sulfide air quality spikes? Flows were 35 to 40 mgd for months, but I believe that we only recently have seen these huge spikes. Flows have also recently dropped to about 14 to 15 mgd during dry weather, but we continue to see spikes in air quality. Okay, I don't know if I can speak to the flow rate changes and how those affect, but and probably this, um, this question comes from, the H2S. You probably know, the hydrogen sulfide results from, that hydrogen sulfide that's in the water. It becomes, as the water aerates and becomes oxidized, the hydrogen sulfide goes into gaseous form, and then we can smell it. Um, and so, at places like Saturn, which is the video that Saturn Boulevard, Trent showed a video there, and that's where we do have a lot of turbulence, and so then it does become airborne there. Um, and so, I mean, it's going to happen regardless of whether the flow is high or low. You'll always get that. But temperature also greatly affects the hydrogen sulfide speciation, and whether it's going to be in the water or in the air, whether it's going to convert to sulfate, and then we won't smell it. So, good question, but I'm not sure if it's a temperature effect, if maybe things warmed up a little bit and then we were able to smell the hydrogen sulfide a little bit more prominently.
Yeah, I would say, Kim Prather's group at UCSD, she's
Yes.
the one who's monitoring a lot of this. Um, she would have a much more authoritative answer. But I think, I agree that temperature is probably one of the main things driving it. We've had record high temperatures this winter, and that can further depress oxygen concentrations in water, can also reduce its ability to hold gas. Um, but again, Kim Prather's group would have the best answer to that question. See, there's another question. What are the trends in the currents and how do these interfere with the distribution of pollutants and with the sensors? Yeah, that's a great question. So the currents shouldn't interfere with the sensor performance themselves. The sensors should be able to detect changes in currents that are reflected in changes in the distribution of the water quality up and down the coast. Um, and I don't know. And again, Scripps and Falk Fedderson's group and Dr. Sarah Giddings' group would know more about how those currents have been changing over time and seasonally. But I do know that Falk Fedderson's group wrote a paper where they documented that the pollution from the San Antonio de los Buenos plant can account for a significant percentage of the total amount of wastewater at Imperial Beach and even Imperial Beach under conditions of northward moving coastal flows. So yeah, spot on that those tidal and well, not tidal conditions, but ocean circulation conditions are extremely important in the resulting pollution distribution.
There's another question. I'm interested in understanding whether you have conducted any research on native plants and native trees that could assist with this issue, as constructing additional water treatment facilities in these areas may endanger the natural habitats. As far as the latter part of that question, the facilities I was talking about, and I was pointing to that recent five pillar report, and the EPA and IBWC composed that report. They were talking about facilities being placed, at least for the expansion for water reuse, the facilities being placed on the existing land of the International Treatment Plant, where there is actually a lot of existing cleared land area where they could place those facilities. As far as the decentralized water reuse, for example, what like Ecoparque in Tijuana, that wastewater that they treat on that landscape is actually used for landscape irrigation, and they're also using it for their nursery where they have native plants. So that is actually, if anything, could be a real positive for promoting more native plants. Some plants really also, like in the estuary, there's a lot of vegetation, and these we think could have a beneficial role in uptake of nutrients, for example, and especially native plants. But when we have altered the system so much with such high nutrient concentrations in the river, those the native plants, at least if we're talking about the estuary, they could have a real hard time. But I definitely agree we should be looking for those types of solutions, and also, coordinating, collaborating with tribal communities, Kumeyaay, who know about the native plants in this region and know what works. So I think there's a lot we can do there. Sorry we didn't mention, but we are working in Kumeyaay land, and all of our research is being done on this whole issue is on Kumeyaay land. So thank you for that question.
Awesome. Any additional questions from folks? Well, I think I might jump in for a couple minutes. I just first huge round of virtual applause for Natalie and Trent. I really appreciate this. There was a really interesting presentation, and you all, we're very fortunate to have you all doing this research in this region on this very challenging issue. So thank you. It raised a bunch of questions in my head that I'd love to ask and continue these discussions. One thing that I noted, I had a couple updates from a tour I just did on Friday. I went down with a kind of a political delegation to the San Antonio plant, and we also toured the South Bay plant. So we've got a couple of updates there. One of the things we learned when we were in Mexico was Trent, to your comment about kind of it'd be great to understand what the water quality is like where the SAB plant discharges into the ocean. Apparently, under the permit that the SAB plant has with the Mexican government, they're required to do monitoring uh, pretty infrequently. I think it's only twice a month that they test their effluent. Um, but apparently, so far, they are not sharing that information with the US, with their counterparts in the US. So there is definitely a good question there, a good information need, data gap that we would love to find ways to address if we could. And I think that would be really valuable data. Um, a couple other things we learned on the tour that I think would be great to share with you all. One is on the for the San Antonio de los Buenos site, and under the recent amendments to the treaty between the US and Mexico, apparently Mexico is committed to exploring and I think looking for funding to plan and build another treatment plant at that site. So they are planning they currently have 18 million gallons per day, which Natalie mentioned. Um, they have plans underway to add an additional plant that could treat up to 25 million gallons per day, which would, if that were feasible and if that were accomplished in the next, let's just say conservatively 3 to 5 years, that would address the remaining kind of flow of untreated wastewater that's going to that location now and still unfortunately, being discharged into the ocean. So some interesting positive development there. There's a lot of uncertainty about the funding in Mexico, but that is part of the negotiations that are happening with the US. And so I know for us as advocates, we're going to continue to support that idea. And then on the flip side, for the South Bay treatment plant here in the US, we did learn some not so great news, which is up until just last week, the EPA and the IBWC, which runs the South Bay treatment plant, have been saying that they could complete the expansion of that plant to 50 million gallons a day by early next year, roughly maybe the middle of next year. Now the concern is because of a lack of funding, that completion, that expansion is going to take until 2031, according to their estimates now. So, this is not unusual. Unfortunately, it's all of these infrastructure fixes are funding dependent, but it'll be very interesting to see what the data looks like as we move forward. even now that we have 18 million gallons a day of treatment in Mexico, we now have at the South Bay plant 35 million gallons a day. So they've done a slight increase to their treatment capacity. Um, so the real question now is, well, are we going to see reductions in river flows due to some infrastructure fixes that we have in Mexico? We haven't seen those really yet, or we are seeing some of them, but we're not, as we were just discussing, we're not seeing a drop in those hydrogen sulfide air impacts to communities in San Diego. But if we see more treatment in Mexico, as we see a longer delay in treatment here, I think there's a lot of I think the data that we're collecting, all of us collectively collecting, is really valuable, and it's hopefully we can use this data in all of our work to inform the policy decisions and the funding decisions that are being made and where that funding is being spent. There's also some California Prop 4 funding that has been allocated to border infrastructure in California, about $45 million. So we're actively working on that to make sure enough of that gets to the Tijuana River region to fix some of the infrastructure and some of the restoration work that needs to happen here. So,
Yep. Well,
looks like one more question. Yeah, thank you.
I would add that a critical data need is the water flow coming out of in the stream going into the ocean at De Los Buenos, in addition to the water quality,
Yeah,
because
just the volume.
the load is super important. Yeah. So Wendy has a question. Do you know if there's anyone studying or monitoring chemicals or wastewater coming from the maquiladoras? Many of them use massive amounts of water, and there's 2006 evidence that they just discharge when it rains into the streets. A documentary in Maquilopolis, where pinning contaminants to specific industrial parks and or any attempt to make U.S. companies accountable, like Apple, Honeywell, DP,
Hmm.
Stryker, et cetera, by parts from the kilodoors. Yeah, so we're monitoring more like domestic sewage issues with bacteria. We do have, and maybe Natalie, you could know more
Well,
about
I
other
mean,
sampling that
Wendy's,
is done.
absolutely right. And I've heard from my colleagues in Mexico that this is absolutely happening. And many companies are U.S. companies discharging, into the creeks, the arroyos, and then that ends up in the Tijuana River. So, we are, when we say sewage, it's not just the domestic sewage, it is also the industrial. I had in my one slide with the different chemicals, there are a lot of industrial chemicals. And there have been a lot of different folks, even from as far back as the 90s, with our colleague Rick Gersberg from San Diego State University, did a nice study on metals. And a lot of these metals are coming from industry. And then there are folks who've been doing in our public health School of Public Health, UNHAHO, HOH, and also Carrie Sant, SANT. They've been looking at specific, chemicals through non-targeted chemical analysis, a lot of, industrial chemicals. I also know at UCSD, I think Prather is also looking at the different chemicals in the water. Now, but connecting those to the maquiladoras, as I've been in this, trying to understand this issue, I've definitely come across studies. I can't remember which one exactly, but I don't know anybody right now actively going out there, and it might be a little bit of a dangerous thing to do, but looking at sampling at those facilities and then showing the evidence. So I think that is something that should be evaluated and um, yeah, it's an important point. Thank you for raising it.
Yeah, I agree.
Absolutely. Thank you. And we are um, we have some more information we could share on maquiladoras. I think what we'll do in the interest of time, I think we're going to wrap it up. But Coastkeeper will follow up with some links related to some of the questions to the presentations we heard today from Natalie and Trent, and answer any questions you have. Looks like there's one more. Great. Wendy, we will follow up probably with the whole list of attendees to share more information going forward. And of course, we're going to continue to share content on what's academics and researchers like Natalie and Trent are doing, what we are doing as an advocacy group. And we really appreciate everyone's time today. Huge thank you to Natalie and Trent for putting this together and for sharing their work with us. So I think we'll we will wrap it up. Thank you all so much. Have a great rest of the
Thanks for
day.
having us.
You
Yeah, thank
betcha.
you. Thanks for having us.
Thank you.